Happy Wednesday, 7th graders. We are almost there. A couple more days here. So we are going to finish up functions here, okay? So today's lesson is a combination of two things that we've kind of done already. We're going to compare functions, and we are going to look at functions when they're linear versus nonlinear. We've already kind of talked about comparing linear equations, and we've already kind of talked about linear versus nonlinear equations as well. So the function piece is very similar to what we were doing before. So this should be pretty quick and easy. So this should be a familiar word, rate of change, all right? We can compare functions by looking at their properties, such as their slope. Okay, remember that's your rate of change. To find that rate of change, we use that slope formula. So that brings us back to that y2 minus y1 divided by x2 minus x1. Or you can compare the ratio of rise over run on a graph. Okay, so let's just quickly review these. You guys should be getting pretty good at this. Find your rate of change for each of the following examples. So you're basically finding your slope for these examples. So which piece is your slope here? Your slope here, or your rate of change, is 2/5, okay? Rate of change here, remember, xy, xy, 1, 1, 2, 2. So what would be your rate of change or your slope here? Okay, there's the work. Our rate of change should be 1.5. Taking a look at number 3. Okay, some of us are still getting tricked up on tables here. So remember, when you look at this, okay, if you think of a rate of change in terms of y2 minus y1, okay, so these are just points. So this is maybe your first point, your first x point. This is maybe your second x point. This is maybe your first y point, your second y point. Okay, remember it's that change in y over change in x. So kind of take a peek here. So what is this changing by? You can look at it like that. So if you think about your y1 to your y2, okay, or if you subtract the difference between these, -11 minus -5 divided by 7 minus 5. Okay, sometimes tables, some of you are catching on pretty quick. You can find the difference between these. To go from -5 to -11 on a number line, you are going up or down. You are going down 6. So if you think about it, and if you think about your double negatives here turning into positives, that keep, change, flip idea, -11 plus 5 is -6. So it changed by -6. To go from 5 to 7 is 2, or if you subtract to find the difference, 7 minus 5 is 2. So -6 divided by 2 is -3 for a rate of change. Rate of change on a graph, okay? This one is not a proportional graph because remember it's not going through our origin here, but it is a linear graph because it creates a straight line or a linear function. They're kind of interchangeable. So my y-intercept is 1. The next point which it crosses nicely is right here. So what is your rise over your run? What is your rate of change or your slope for this one? My rate of change here is 1/4. Rise 1, run 4. This is a positive slope, positive uphill line. So let's take a look down here on number 5. Ty sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. His friend Harrison helps him make signs at the rate, and the rate of which Harrison makes signs is in the table below. Who is making signs at a greater rate, and how do you know? So we have Ty. He can make 7 signs every 2 hours, okay? And we know Harrison down here, he's making 15 signs every 4 hours, 30 signs every 8 hours, 45 signs every 12 hours, okay? So here, the greater rate, okay? So your rate is how many signs per hour. So Ty can make 7 signs in 2 hours. So if we divide that and find our unit rate in order to be able to compare, he can make on average about 3.5 signs per hour. Harrison here, if he can make 15 signs in 4 hours, if you go ahead and divide that, 15 divided by 4 is 3.75. Remember, that's just kind of on average. But with you getting your unit rate for these are now easy to compare. So if you want to just double check, if you throw in 30 divided by 8, that also gives you 3.75. And if you throw in 45 divided by 12, that also gives you 3.75. So this is a consistent table. Now, once you have the unit rate here, if you're trying to find who has the greater rate, okay, sometimes that's one thing you can do. The other thing you can do is some of you might have said, well, I can see Harrison did 15 signs in 4 hours, 7 signs in 2 hours. If you doubled your hours here, 4 hours, you doubled 7, that would be 14. Who makes more? You can look at it that way as well. Okay, who's working at a greater rate? 3.75 is greater than 3.5. If you doubled that, that would be 14 in 4 hours. Okay, so 15 signs is greater than 14 signs in the same amount of hours. So Harrison has the greater rate because 3.75 is greater than 3.5. You could also write 15 in 4 hours is greater than 14 in 4 hours. Does that make sense? So this is signs per hour. So part B asks, after 12 hours, what would the difference in the number of signs that each friend has made? So that's why right here, this makes it a little bit nicer once you have the unit rate, because once you know how many signs on average per 1 hour, that makes it easy to find any amount of hours. So for 12 hours, all we're going to do is take each of their unit rates and multiply those by 12. So 3.5 times 12, Ty can make 42 signs in 12 hours. Harrison, 3.75 times 12, can make 45 signs in 12 hours. So the question asks, what would the difference be? Whoop, sorry. Difference would be 3. Julie's family is filling up the pool in her backyard. The equation y equals 5.2x plus 8,400 can be used to show the rate at which the pool is filling up with water, where y is your total amount of water in gallons, and x is the amount of time in minutes. Okay? Her neighbor, Elena, is also filling up the pool as shown in the table below. So Julie's up here. This is the equation of Julie. Elena is down here in a table. How could we get the equation of the table, or how could we find whose pool is filling up at a faster rate? Doesn't ask where it's starting. Okay, so let's write the equation for this table. First, in order to write the equation, so here's our equation up here. We want it to look similar to that. Y equals, so we need our M, our slope, or our rate of change. So what's our change in our Y over our change in our X? Change in my Y value, I subtracted these two values, is 14.4. The difference in the X values, or the change in the X values, is 3. So remember, in order to find your slope here, we're going to divide our change in our Y divided by our change in our X. So when you divide that, we get 4.8x. Now, remember, this is our y-intercept. This is where the graph begins. So take a peek in our table. What number in our table do you think shows the y-intercept? Right here at 0. Okay, at 0, we're going to go up 7,850. So think about your graph if we're talking about this quadrant. At 0, we're going up 7,850. So that's going to be your y-intercept. Okay, so when x is 0, right here. The x-axis is here. The y-axis is here. So when x is 0, that's going to go up or down, depending on if that was positive or negative. That was your y-intercept. So my y-intercept is a positive 7,850. So Elena's equation is represented right here. Julie's is represented right here. The question is asking whose pool is filling up at a faster rate. So which numbers do we care about? We care about the slope. How many gallons of water are at the start don't matter. That's not what the question's asking. So whose pool fills up at a faster rate? The answer would be Julie. Why? Because 5.2 is greater than 4.8. Okay, number 7. Compare the slope in each of the equations below. Circle the equation that has a greater rate of change. So what I want us to do is it hard to find your rate of change here? What do you need to do to both of these equations in order to find the rate of change or slope? We should be getting them into slope-intercept form. So first, get this equation into slope-intercept form. Is y equals 3x plus 9 in the slope-intercept form. So what is your rate of change there? Go ahead, get this equation into slope-intercept form. For this in slope-intercept form is y equals 3/4 x plus 6. What is your rate of change for this equation? So let's circle the equation that has the greater rate of change. This equation has a larger rate of change. 3 is greater than 3/4. Okay. Number 8. Compare the slope in the equation y equals 3/5 x plus 2 with the slope in the ordered pairs below. What is the rate of change, or what is the greater rate of change? So what is our rate of change for this equation? Our slope or our rate of change is 3/5 here. So remember, to find your rate of change in ordered pairs, remember, it's just like a table. Here's your x values, here's your y values. Okay, there we go. Okay, change in y's. So if it goes from 2.6 to 3.8, if you subtract that, 3.8 minus 2.6, 3 minus 1, remember x2 minus x1, that gives us an easy 2. Subtract these two, 1.2. When you divide that out, 1.2 divided by 2 is equal to 0.6. Okay, so my rate of change is 0.6 down here. What is 3/5 equivalent to? Okay, remember it's not very nice and easy to compare fractions with decimals, so make them the same. Typically, I think most of you think that changing a fraction to a decimal is easier. 3/5, okay, is equal to what? So if you have 5 questions on a test, how many are each worth? 20 points, 20, 40, 60, 80, 100. So if you have 3 out of 5 questions, you're going to get a 20, 40, 60. 60 out of 100 is equivalent to 0.60. So who has the greater rate of change? They're both the same. Okay, last one for this. Reese and Kevin have been working out together and to try and lose weight. Reese's weight loss can be modeled by the equation y equals negative 4x plus 203. So let's talk about this. Y is his total weight. X is the number of weeks he's been working out. So he is losing 4 pounds per week. Remember, this is our y-intercept. This is where he begins. So Reese must be beginning his weight loss journey at 203 pounds. So he starts at 203 pounds. He's losing 4 pounds per week. All right, that's what that equation means. Kevin's weight loss program is shown at the graph below. Who is losing weight at a faster rate? So I want you to write me an equation for this graph. I'm going to help you out. I think you guys can see the y-intercept pretty easily. That number is 200. The next point where it crosses perfectly is right here. Be careful, look at your axes numbers. I'm going to move this up just a little. Okay, what would be the equation for Kevin? Writing my equation here, I know I need y equals mx plus b. Here's my b. My y-intercept is positive 200. My m, my slope, it goes down 20 over 4 weeks. So down 20 is negative 20 divided by 4 is negative 5. So Kevin's equation is represented by y equals negative 5x plus 200. Reese's equation is y equals negative 4x plus 203. So what this means is Kevin is starting out at 200 pounds and he is losing 5 pounds per week. Remember, x stands for the number of weeks. Y is the weight. Okay, so if we wanted to know what his weight was after 3 weeks, we would plug in 3 for weeks, solve this, and that would tell us what Kevin's weight would be at. Okay, so who is losing weight at a faster rate? What do we care about here? Our rate is our slope. So Reese is losing 4 pounds per week. Kevin's losing 5 pounds per week. So who's losing weight at a faster rate? Kevin is. Why? Because losing 5 pounds per week is greater than losing 4 pounds per week. Nonlinear functions. So a linear function, we've talked about this, okay, is a function that will make a straight line when it is graphed, okay? So it doesn't necessarily have to pass through the origin. All it means is if it passes through the origin, then it's proportional. So as long as it makes a straight line, then it's linear. So far, that's all you guys have learned how to graph. In algebra next year, you guys will learn how to graph different parabolas, quadratics, exponential functions, all things that are different than a straight line. Okay, so an equation is linear if it can be written in the form of, you guys should know this by now, y equals mx plus b, where m is your slope, b is your y-intercept. So a table is linear if it shows a constant rate of change. We talked about that in the last lesson. And it's got to stay constant throughout the entire table. So we're just going to do a couple examples here, and then you guys can get to going on your classwork. In the following examples, you'll use functions to fill out a table of values and create a graph. Look for any patterns among the functions that make it linear, and then those that are not linear. So take a peek here. First, is this equation written in y equals mx plus b form? It is not. Why not? Because it has the exponent of 2 here. Okay, so if you had to guess, do you think this would be a linear equation? What about this one? Is this written in y equals mx plus b form? This one is written in y equals mx plus b form. It just has a b or a y-intercept value of what? Should be 0. Okay, so how we can do these, once you're given an equation, to fill in this table and then to go graph these coordinate pairs, or ordered pairs, however you want to look at it, all we're going to do is we're going to plug in these numbers. So if this x value is -2, -2 squared is -2 times -2, which is +4. +4 plus 1 is 5. -1 squared. -1 times -1 is 1. 1 plus 1 is 2. 0 squared. 0 is always my favorite to plug in. 0 times 0 is 0. 0 plus 1 is 1. 1 squared. 1 times 1 is 1. Plus 1 is 2. 2 squared. 2 squared is 4, plus 1 is 5. What do you notice about that? This is getting into something you're going to really get to know a lot more about in algebra. So this kind of looks like a mirror, right? Middle. And then those are the same. Those are the same. So this is not going to be linear. So let's go graph these. -2, 5. These are like ordered pair. X, then Y. -2, 5. -1, 2. 0, 1. 1, 2. And 2, 5. What does that create? Kind of creates a U. Well, it's certainly not linear. Doesn't create a straight line. This is called a quadratic, okay? And you're going to see a U-shaped anytime you see a squared on your X. So is this function linear? No. Constant or straight? Okay. Let's take a look at this one. Plug this in. What's -4 for my X value? What's half of -4? -2. What's half of -2? -1. What's half of 0? Anything times 0 is always 0. Half of 2 is 1. Half of 4 is 2. Okay, so let's take a look at, go back, I want to apply something that we learned in Monday's lesson. Okay, so this is a function because all X values have their one and only one Y value. There are no repeating X values here that have a different Y value. So yes, it's a function, but the question asks, is the function linear? So we said, no, it's not a linear function. So now this one is a function. There are no repeating X values with different Y values. So no vending machines where you push the button and you get two different outcomes. This is a working function, okay? So when you go to graph this equation is written in y equals mx plus b form. Okay, this is also a proportional relationship because it passes through the origin. So is this function linear? Yes, we just discussed why, because it's a straight line. All right, so what do you notice the difference about the functions in question 1 and question 2? When it's linear, it's got to be written in y equals mx plus b form. When it's not linear, it won't be written in that form. When it's x squared, it'll create a u there. We call that cubed, okay? So we're going to plug in our x values here. -2 to the third power is really just -2 times -2 times -2. Negative times a negative is a positive. Positive times a negative is a negative. So I know my answer is going to be negative. 2 times 2 is 4. 4 times 2 is 8. -1 cubed is -1 times -1 times -1, which an odd number of negatives, remember we talked about that earlier in the 7th grade year, an odd number of negatives is going to get us a negative. 1 cubed is 1. 0 is nice. 0 times 0 times 0 is always 0. 1 cubed is 1 times 1 times 1, which is 1. 2 cubed, 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay, so is this a function? The answer is yes. Every x value has its own y value. Is it a linear function? Okay, what do you think? These are real far apart. So when I go to graph this, it looks like that. Is that a linear function? No. Why? Because it's not written in y equals mx plus b form. It's got the x cubed there. All right, number 4. This is written in y equals mx plus b form. So what do you think? Do you think this is going to be linear? Let's fill in the table. And we read it wrong and graphed it. So there you can see the points. Those create a nice straight line. So it is a linear function. All right, last one here. So we plug in 1. 12 divided by 1 is 12. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 6 is 2. So let's graph this. Nonlinear. Hopefully you're saying nonlinear. Okay, so that is your quick lesson on linear versus nonlinear. Now you can work on your classwork for today. Have a great Wednesday. I'll see you Friday.